Every day in the United States, folks toss out 27,000 microwave ovens. That's nearly 2.5 million a year. But what happens to them once they're kaput? You'll be shocked at how wild the recycling process gets. From tearing apart transformers packed with hazardous stuff to digging out gold from circuit boards, every step is a jaw-dropper. How do factories handle hundreds of tons of metal daily? Why do magnetrons need special treatment? And what's the deal with the plastic parts? Stick around to the end to uncover the secrets of e-waste recycling. Recycling microwave ovens in the United States of America is a tricky business, involving a bunch of steps, all geared toward cutting down environmental harm and squeezing every bit of reusable material out of them. It all kicks off with properly disposing of the oven according to local rules and laws. Tons of towns have special e-waste drop-off spots where people can hand over their old appliances. Plus, big retail chains and microwave makers often run take-back programs, sometimes even tossing in discounts on new buys as a sweet deal. Once the thing lands at a recycling center, the first move is breaking it down and sorting out the main parts. This happens at specialized e-waste recycling hubs or appliance recycling plants. These places are scattered across the United States, mostly clustered in industrial zones or near big cities where electronic junk piles up fast. Some are private outfits, while others roll under city-run recycling efforts. First off, workers figure out if the oven can be reused or if it's headed for a full teardown. If the microwave's in rough shape, it goes straight to the disassembly line. They start by yanking off the outer shell, usually made of steel or aluminum. Breaking down microwave ovens can happen by hand or with machines. In smaller recycling spots, most of the work's done manually with basic tools like electric screwdrivers, pliers, hydraulic shears, and teardown stations. They unscrew the outer metal panels first, popping open access to the guts inside. Workers pull out the big pieces, like the magnetron, transformer, circuit boards, and wiring. The metal bits get squashed and shipped off to steel mills, where they're melted down for reuse. Inside every microwave is a magnetron, the thing that pumps out those microwaves. It's got ceramic insulators, copper coils, and a tiny bit of toxic stuff, like beryllium. Since beryllium dust can be nasty, magnetrons get handled with care, using protective gear and special recycling tricks. At big industrial recycling centers, they roll out automated teardown lines. A key player here is the electronic shredder. Think machines like the hammer mill or SSI dual shear, stretching 15 to 20 feet long and chewing through hundreds of microwaves an hour. After shredding, the materials hit magnetic separators, which pull steel apart from the rest. At heavy-duty plants, teardown's a multi-step gig with fancy machines. For transformers, they use hydraulic cracking presses to bust open the casing and get at the copper or aluminum windings. To snag precious metals from circuit boards, they dunk them in chemical baths or fire them up in furnaces at over 2,000 degrees Fahrenheit to melt out the good stuff. On average, big plants can rip apart 500 to 1,000 microwave ovens a day, depending on how much gear comes in and how automated they are. At smaller outfits, where it's mostly handwork, they process 50 to 200 units daily. Next, they yank out the circuit boards, loaded with resistors, capacitors, and microchips. These get handed off to companies that extract precious metals like gold, silver, and palladium. The copper wiring inside gets peeled out and recycled too. While exact numbers on precious metals from microwaves in the United States are hard to pin down, e-waste recycling overall brings a hefty haul of valuable materials back into the game. Another big piece is the high-voltage transformer, made of a metal core and copper or aluminum windings. Since it's got insulation that could be risky, recycling it takes some extra steps. The main hassle with transformers is their density and toughness, making it a chore to pull out the materials fast. Teardown starts by prying the transformer loose from the microwave's shell. This happens manually or with electric screwdrivers and teardown stations. Then it's hauled to the recycling zone. If it's by hand, workers use hydraulic shears, grinders, or metal cutting presses to slice open the outer casing. The transformer's core, usually layered steel, needs serious muscle to split, so big plants lean on industrial shredders or hydraulic presses. One slick way to crack transformers is with special crushing presses that smash the casing, letting workers fish out the insides. After that, the copper or aluminum windings get peeled off the core and sent for melting. Magnetic separators sort out the steel from the rest. Shredded bits ride a conveyor belt, and as they pass under a magnet, ferromagnetic stuff, like steel plates and transformer cores, sticks to it, then drops into a separate bin. Another type, the drum magnetic separator, uses a spinning magnetic drum. Shredded materials roll onto it, and magnetic force grabs the iron bits, spinning them along until they fall off into their own container once they're out of the magnetic zone. Beyond the mechanical approach, some plants use heat to break down insulation. Transformers get roasted in special furnaces at 1,000 to 2,000 degrees Fahrenheit to burn off organic junk and free up the metals. In some cases, they go with chemical leaching, soaking the transformer in acid, or alkaline baths to dissolve certain parts. Extra caution's needed with the insulation, since it might hold toxic stuff. Older models, for instance, used varnishes with polychlorinated biphenyls, nasty chemicals. So recycling those means wearing protective gear and sending the waste to special hazardous material plants. One slick way to crack transformers is with special crushing presses that smash the casing, letting workers fish out the insides. After that, the copper or aluminum windings get peeled off the core and sent for melting. Magnetic separators sort out the steel from the rest. Shredded bits ride a conveyor belt, and as they pass under a magnet, ferromagnetic stuff, like steel plates and transformer cores, sticks to it, then drops into a separate bin. Another type, the drum magnetic separator, uses a spinning magnetic drum. Shredded materials roll onto it, and magnetic force grabs the iron bits, spinning them along until they fall off into their own container once they're out of the magnetic zone. According to the United States Environmental Protection Agency, about 25% of e-waste, including microwave ovens, gets recycled. Every day, around 27,000 microwaves get retired across the United States, adding up to roughly 2.5 million a year. Recycling cuts down on landfill clutter, helping keep soil and water free of toxic leaks from electronic gear. Properly handling hazardous parts, like capacitors or insulation, stops harmful stuff from hitting the environment, which is a win for people's health and ecosystems. Every single year, more than 200,000 hydrocycles are sold all around the globe, and the overall market for this type of equipment exceeds $2.5 billion United States of America dollars. But how does a piece of composite material turn into a genuine water monster that can accelerate up to 70 miles per hour? What makes the Japanese Yamaha factory the largest hydrocycle manufacturer in the entire world? From automated hull molding to the most advanced engines and on-water testing, today we are going to unveil every secret of their production. Fasten your seatbelts, because we are heading into a realm of high speeds and groundbreaking innovations. The design of hydrocycles begins with conceptual ideas and essential requirements for technical specifications. The very first stage involves identifying the target audience and the purpose of the hydrocycle. It can be a recreational model, a sports or extreme hydrocycle, or even specialized versions for fishing or rescue operations. Designers and engineers must consider not only the visual appeal, but also factors such as maneuverability, stability, top speed, comfort, and water safety. They carefully think through each detail so that the final product meets the needs of both beginners and seasoned riders. According to Statista, The global hydrocycle market by the year 2027 will grow to over $2.5 billion United States of America dollars, with an annual growth rate of 8.3%. This impressive forecast shows just how much interest hydrocycles continue to generate in different parts of the world, especially as new technology makes them more efficient, eco-friendly, and fun to ride. One of the biggest markets for hydrocycles is the United States of America, where more than half of all hydrocycles worldwide are sold. This country remains a leader in water sports development, partly because of its numerous resorts, lakes, rivers, and coastlines, which make hydrocycles immensely popular among both local residents and tourists. Hydrocycles are also well liked in Australia and Japan, where water activities are an integral part of cultural traditions, and people love to explore different forms of aquatic adventure. During the development stage, important factors include the design of the hull, which must be light yet strong and resistant to mechanical damage. For this purpose, high-quality materials such as fiberglass, composites, and aluminum are used to achieve the required rigidity without adding too much weight to the hydrocycle. Another critical consideration is the choice of engine. Most hydrocycles use internal combustion engines, although a growing number of manufacturers are experimenting with electric models, which offer cleaner emissions and produce less noise. In modern hydrocycle design, special attention is paid to innovative technologies, including digital control systems, integration of the global positioning system, and sensors for monitoring the condition of the equipment and improving navigation. These features not only make the experience more convenient for the rider, but they also boost overall safety through automatic stability control systems or engine rotation alerts. All of this simplifies the hydrocycle piloting process and makes it safer, even for first-time enthusiasts. The United States of America holds over 50% of the global hydrocycle market. Another notable trend is the rising demand for electric hydrocycles. Although they currently occupy only a small share of the market, their environmental advantages could make them a key part of the hydrocycle industry's future, since they help reduce emissions and lower noise pollution levels on the water. An essential element of design involves creating an ergonomic layout that ensures comfort during lengthy rides or races. Seats must be comfortable and provide proper support for the rider's posture, while also featuring a non-slip surface that holds up in wet conditions. Additionally, hydrocycles are equipped with various features, such as extra storage compartments, waterproof pouches, and cooling systems that help the vehicle operate at high revolutions over long periods. Developing new models also requires numerous water tests to check how the hydrocycle performs in real conditions. This process helps identify any weaknesses in the design or technical parameters, which are then corrected before the start of mass production, guaranteeing that customers receive a high-quality product. The hydrocycle development process is extremely detailed and demands meticulous attention at every phase, from designing the hull to testing the final product. Engineers, designers, and manufacturing specialists must work in close collaboration to produce equipment that is not just powerful and fast, but also safe and comfortable for users. Hydrocycles need to be easy to maneuver on the water, while also having enough durability to withstand heavy loads, water pressure, salt, ultraviolet radiation, and other environmental factors. These stringent requirements mean that the choice of materials for different hydrocycle components must be carefully evaluated to balance weight, strength, and resistance to corrosive elements. First and foremost, a key element of any hydrocycle's construction is its hull. This is one of the main parts that must be strong enough to resist mechanical damage and, at the same time, provide optimal hydrodynamic characteristics. The most common materials for hull manufacturing include fiberglass, composite substances, and aluminum. Fiberglass is selected because it offers high strength at a low weight and is resistant to corrosion, making it ideal for use in aquatic environments. In addition, it can be molded easily, allowing engineers to create sleek, aerodynamic shapes for the hydrocycle hull. Composite materials, which include polymers reinforced with fibers such as carbon or Kevlar, are even more advanced, delivering greater strength while reducing weight. They also exhibit excellent resistance to ultraviolet exposure and chemical agents like salty water solutions. By combining these materials, manufacturers can cut down on hydrocycle weight while improving speed and maneuverability. which is especially beneficial for sports-oriented models. When it comes to internal components, such as fuel tanks and cooling systems, manufacturers often rely on stainless steel or specialized plastic blends. Stainless steel is a long-lasting material that resists corrosion, making it perfect for repeated contact with water and various liquids. Plastic blends, such as high-density polyethylene, are used due to their lightness, durability against chemical and mechanical impact, and ability to function effectively for extended periods in high humidity conditions. Another crucial consideration is the choice of materials for hydrocycle engines. Lightweight yet powerful substances are essential for achieving high revolutions without sacrificing endurance. Typically, engine components are made from metal alloys, including aluminum, titanium alloys, or magnesium. These materials have low density, which helps reduce engine weight, and they have excellent thermal conductivity, which is critical for efficient cooling and overall engine performance. One well-known hydrocycle manufacturing facility is located in Japan, operated by Yamaha Motor Company, which is widely recognized as one of the leading brands in the watercraft market. Situated in the city of Iwata in Shizuoka Prefecture, this factory produces not only hydrocycles, but also other types of water transport and their engines. The Yamaha Motor Factory spans approximately 250 acres, making it one of the largest facilities in the world dedicated to water equipment production, including hydrocycles. The site specializes in manufacturing a broad range of water transport products, including diverse hydrocycle models, boats, yachts, and other motorized water vehicles. Every year, this factory turns out thousands of products, including over 60,000 hydrocycles annually, which secures Yamaha a substantial market share in the water transport sector. Thanks to the factory's expansive premises, every stage of production, from assembly to testing and packaging, can be carried out efficiently and in one location. One of the main automated lines is responsible for forming hydrocycle hulls using materials such as fiberglass and composites. This line is equipped with robotic arms that precisely shape and join individual hull components, delivering the exact design contours and a smooth exterior finish. In addition, automated welding and painting systems are used to process metal parts, such as engines and their subsystems. The line features robotic welding machines that provide accurate, high-quality welds, as well as automated painting systems that evenly coat components and offer reliable protection against corrosion. This advanced technology helps ensure the product maintains a pristine appearance and robust structure over an extended service life. The assembly lines have a real-time quality control system, which automatically identifies defects at any stage of production. This includes visual inspections using cameras and scanners capable of detecting even the smallest flaws in parts, allowing the factory to preserve the highest possible product quality. A distinctive feature of this factory is its extensive automation in the packaging and shipping phases. Once hydrocycles have passed all quality checks, they move on to automated packaging lines, where robotized systems assemble boxes and secure the hydrocycles inside transport containers. This process enhances shipping safety and streamlines logistics, ensuring that the products are delivered to customers in excellent condition and on schedule. The Yamaha factory continuously adopts the latest technologies in water equipment production. For instance, they use three-dimensional printing to create prototypes of new models, enabling faster testing and refinement of their designs. Moreover, the facility employs pioneering materials that help reduce the weight of hydrocycles, increase their corrosion resistance, and extend their service life. They also make active use of intelligent production management systems, which optimize manufacturing processes, cut down on costs, and shorten the time needed to produce each unit. As a result, the factory can expedite hydrocycle manufacturing and boost output volume, illustrating Yamaha's commitment to continuous innovation and leadership in the fast-paced world of hydrocycle development. Every year, between 80 billion and 150 billion units of Adidas clothing are produced worldwide. But what about footwear, which holds the second largest production volume in the world? Recently, Adidas has seen a significant surge in popularity for its retro models, such as Samba, Campus, and Handball Special. According to the online platform StockX, Adidas sales increased by 51% compared to the previous year. Let us dive into the production of these legendary sneakers and see how new footwear is brought to life. The process of creating a new Adidas shoe model begins long before the first physical samples reach the production line. Dozens of specialists from different fields take part in this process: designers, marketers, engineers, technologists, and even sports consultants. Adidas designers constantly analyze market trends, researching which models are currently in demand, which technologies are evolving, and what consumers prefer. This includes analyzing past sales data, studying fashion trends in streetwear and sportswear, monitoring competitors such as Nike, Puma, and New Balance, tracking new materials and innovations in manufacturing, and conducting surveys with professional athletes and regular users. This process can take anywhere from several weeks to several months, depending on whether it involves updating an existing line or creating an entirely new concept. Once the team gathers enough information, the concept development phase begins. Designers create the first sketches, plan the shape, position logos, and select material and color combinations. At this stage, it is crucial to find the perfect balance between style, functionality, and comfort. Interestingly, Adidas frequently uses specialized three-dimensional modeling software that allows designers to create realistic digital images of future shoes. This helps save time and provides a more accurate visualization of how the model will look in reality. This exciting process can involve anywhere from 10 to 50 people, depending on the complexity of the project. This includes not only designers, but also biomechanics specialists who assess comfort and foot impact, technologists responsible for materials, and even marketers who propose changes to meet consumer expectations. Designers may suggest a stylish solution, but if it is uncomfortable or does not meet technical requirements, such as weight, material durability, or breathability, it must be revised. Some ideas are impossible to implement due to technological constraints or excessively high production costs. Adidas is actively working to reduce environmental impact using recycled materials and eco-friendly technologies, which also influence design decisions. After the first physical prototypes are created, Adidas puts them through rigorous testing to evaluate comfort, durability, and compliance with stated characteristics. This stage assesses material quality, seam strength, and overall resilience before launching the model into mass production. Shoes are placed in specialized machines that simulate walking or running through thousands of cycles to test the wear resistance of the sole and upper materials. The sole bends thousands of times to check for cracks or deformations. The shoes are submerged in water or exposed to moisture to test their resistance to soaking. The force required to tear fabric, seams, or glued elements is measured. Adidas employs robotic systems that replicate real-life usage conditions. Special robots simulate foot movements during running, jumping, and sharp turns. Shoes are subjected to extreme temperatures to assess material behavior. Shock absorption and impact resistance are analyzed using sensor platforms. No footwear enters mass production without undergoing real-world testing. Adidas collaborates with professional athletes who wear new models during training and provide feedback. Key testing aspects include comfort during running, jumping, and prolonged wear, foot and ankle support, breathability, and adaptation to different surfaces such as asphalt, grass, and hardwood floors. All these stages can take anywhere from several months to a year, depending on the model's complexity and the number of necessary adjustments. If a prototype fails testing, it returns for further refinement. Adidas works with suppliers worldwide. For example, the Boost sole was developed in collaboration with the German chemical company BASF. This revolutionary sole consists of thousands of expanded thermoplastic polyurethane pellets that provide high energy return. Once all necessary materials arrive at the manufacturing facility, one of the most crucial stages begins: cutting and preparing shoe components. From large fabric or leather rolls to sheets of synthetic materials, all components are placed in designated cutting zones. Workers or automated systems load materials into cutting machines according to the production plan. Modern Adidas factories use automated feeders that evenly unroll fabric or rubber for precise cutting. Laser cutting is used for thin synthetic materials and mesh fabrics like prime knit, as well as for intricate designs requiring high precision. Mechanical cutting is performed using press cutters or automatic knives following program templates. This method is ideal for leather components and thick fabrics. High-precision computer numerical control cutting machines can simultaneously cut hundreds of pieces from different materials, significantly accelerating the process. To minimize waste, software analyzes the most efficient way to position shapes on the material. Leftover scraps from cutting may be used for smaller components or other shoe models. Some recycled materials, such as Parley Ocean plastic, undergo secondary processing for reuse in future products. After cutting, components undergo additional technological treatments to achieve the required properties. Lamination is used to reinforce fabric and improve its performance characteristics. For example, running shoes may feature multi-layer lamination to enhance waterproofing and durability. This process includes applying special polymer coatings or thermal adhesives to increase material strength. Some shoe elements, especially those containing thermoplastic components, go through a heat molding process. When heated to a specific temperature, the material becomes pliable and takes the desired shape. Once cooled, it retains its structure. This method is used to create rigid heel cups or supportive inserts in the sole. Adidas employs several branding techniques for footwear. Thermal printing embeds logos and textured patterns into fabric or leather under high temperatures. Embossing creates raised logos on leather and synthetic components. Embroidery is used on textile models, such as the Stan Smith series. Reflective coatings enhance visibility in low-light conditions. Right now, take a closer look at your sneakers and comment on which branding method was used on them. Cutting takes anywhere from several minutes to an hour, depending on model complexity and materials used. Component preparation, including lamination, heat treatment, and logo application, can take several hours to a full day, as some steps require drying or curing time. Can you believe how much time goes into something that seems so simple? Incredible. The entire process is automated, but key stages involve operators who monitor quality and make adjustments. Adidas is currently experimenting with three-dimensional printing of shoe components, which could revolutionize cutting processes. Laser cutting also enables the creation of complex ventilation holes in shoes without additional stitching. Using laminated materials improves waterproofing without increasing shoe weight. After completing all preparatory stages, the finished components move to the next critical phase, sewing and shoe assembly, where they begin to take their final shape. Sewing machines join individual shoe upper parts, ensuring durability and a polished aesthetic. Adidas production lines use specialized automated sewing machines that operate at high speed and run continuously for extended periods. These machines execute various stitch patterns with precision, ensuring both strength and clean seams. As materials pass through multi-step mechanisms, needles create perfectly aligned stitches that form even and neat seams, enhancing shoe durability and longevity. Once all upper shoe parts are combined into a unified structure, the machine completes the final touches, reinforcing stitches, securing details, and performing quality control. Every component is perfectly aligned and interconnected. As a result, nearly finished footwear emerges, transformed into a functional and stylish product through a blend of mechanical precision and human craftsmanship. Some models feature seamless technology to enhance comfort and reduce weight. Soles are formed by molding material under high pressure to achieve the required shape and properties. Once the upper shoe parts are stitched together, the next step is attaching them to the sole. High-quality adhesives are applied to specially prepared surfaces. These adhesives create a secure bond between components, preventing detachment during wear. Next, shoes pass through a conveyor system, where each pair enters specialized pressing machines. These machines use high pressure and temperature to tightly fuse the sole and upper, ensuring a strong bond. The conveyor smoothly moves each pair through multiple stages, from adhesive application to pressing, undergoing a series of heating and cooling cycles to finalize the adhesion process, making the shoes durable and ready for further stages. Every year, more than 500 billion matches are produced worldwide. That means around 16,000 matches ignite every second. But have you ever wondered how these tiny wooden sticks go through a complex manufacturing process before they end up in your hands? Today, we are diving into the fascinating world of match production. From selecting the right wood to applying the chemical coating that allows them to ignite with a single strike. You will learn how modern factories produce millions of matches daily, what materials they use, and why matches continue to thrive in the market even in the 21st century. The matches we are familiar with first appeared in the 19th century. Let's take a detailed look at each stage of match production. I will tell you all about it, from raw material selection to packaging the final product. The primary material for matchsticks is wood, carefully chosen for its properties. Softwood species are mostly used. Aspen has a uniform structure, is easy to process, does not crack, and provides consistent burning. Poplar is known for being lightweight and widely available. Pine is used less frequently due to its high resin content, but in some regions, it is carefully treated to remove the resin before use. Many manufacturers aim to use waste from the woodworking industry, reducing costs and making production more eco-friendly. The wood is stripped of its bark, sorted, and cut into transportable logs before being sent to the factory. At the factory, the wood is loaded into special drums for cleaning. The logs are then sliced into thin sheets, resembling ribbons. This is done using precision machines with adjustable blades. The ribbons undergo thickness uniformity checks since the quality of the final match depends on it. After slicing the ribbons, they are cut into individual matchsticks. On average, a standard match measures between 1.65 inches and 1.77 inches in length, with a thickness of approximately 0.79 inches. Tell me, did you just measure that too? I do not want to be the only one doing it. The blanks then go through a drying system, reducing their moisture content to an optimal level, no more than 6 or 8%. For additional protection, the blanks are treated with antiseptic solutions to prevent mold, fungi, and insect damage. After this treatment, the matchsticks move to the assembly conveyor. The chemical mixture for match heads is prepared in separate facilities. It is a complex combination of several key components. Oxidizers release oxygen during combustion. Sulfur or other flammable substances ensure stable burning. Phosphorus is the main element that enables instant ignition upon friction. Dyes give the heads their characteristic colors: red, green, black, and more. Adhesives bind the components together. The ingredients are mixed in specialized equipment, and the finished mixture is poured into storage tanks. For worker safety and to prevent spontaneous combustion, all operations take place in explosion-proof rooms with strict temperature control. By the way, did you know that in the year 1826, English pharmacist John Walker invented friction matches? His friction matches consisted of a stick coated with a mixture of antimony sulfide and potassium chlorate. Then, in the 1830s, Frenchman Charles Sourier improved them by using red phosphorus, which was less toxic and safer than yellow phosphorus. These matches could ignite only when struck against a specially prepared surface on the box, becoming the prototype of modern safety matches. After applying the chemical mixture, the matchsticks are sent to drying chambers. Here, they undergo a drying process that lasts approximately 2 or 3 hours. These chambers maintain a controlled temperature, ensuring the mixture solidifies evenly. This treatment gives the match heads the necessary strength to prevent crumbling or flaking, even during long-term storage or transportation. This stage is crucial since it forms the core functional part of the match, the head, which ensures its usability and durability. Thanks to modern technology and rigorous quality control, the final product is not only convenient, but also entirely safe for users. While the matches are drying, a separate production line manufactures matchboxes. Cardboard is used, going through several steps, which we will now explore together. Step 1. Cutting sheets into blanks. Step 2. Printing labels, which may include either simple manufacturer information or colorful designs depending on the order. Step 3. Forming the boxes using specialized machines that fold and glue them together. Next, a special abrasive coating is applied to the inner side of the matchbox. This mixture of phosphorus, glue, and quartz sand ensures match ignition. Afterward, the dried matches move onto a conveyor belt, where they are cut to a perfectly uniform length. Then, precision dosing machines distribute the matchsticks into the boxes. Each box is filled with an exact number of matches, usually 40, 50, or 100, depending on the format. Once filled, the boxes are automatically sealed and sent to the packaging line for shipping and storage. The finished match blocks are labeled and sorted onto pallets before being loaded onto trucks for delivery to stores or wholesale suppliers. Now we are in the final stretch of match production, the concluding stage that wraps up this long, intricate, and carefully planned process. At this stage, the finished matchboxes are carefully grouped into bundles, usually containing 10 or 12 boxes. These bundles are tightly wrapped in transparent polyethylene film, which serves several important functions. First, this packaging protects the matches from moisture, preserving their quality during transportation and long-term storage. Second, it makes the products easier to handle and distribute. After packaging, the bundles are labeled according to logistics requirements. Each package includes information about the manufacturer, production date, batch number, and other necessary details. The products are then arranged on pallets, optimizing transportation efficiency. Loaded pallets are transported to trucks, which deliver the finished matches to stores, wholesale warehouses, or even export them abroad. It is important to note that strict quality control is conducted at every stage of the production process. This ensures that the matches meet high standards and satisfy consumer expectations. The wood's uniformity is checked to ensure it is strong, free of cracks and defects, as it forms the foundation of every match. The durability of the match heads is tested to ensure the chemical composition does not crumble or flake, making the matches reliable for use. The ease of ignition against the abrasive surface is controlled, ensuring matches ignite on the first strike while remaining safe for transportation. Match production is a combination of high-tech equipment, natural raw materials, and strict quality control. Each match goes through dozens of steps before reaching store shelves and, ultimately, your hands. Thanks to automation, eco-friendliness, and safe working conditions, the match industry remains an essential part of many economies. Match production is a complex, multi-stage process that integrates modern high-tech equipment, natural raw materials, and strict control at every stage. The process begins with material preparation, including wood and special chemical mixtures for coating match heads, and ends with packaging the final product. Each individual match undergoes dozens of technological operations, including wood processing, chemical application, drying, and quality inspection before reaching store shelves. Automation and eco-friendly technologies ensure that modern match production meets high safety standards for both workers and the environment. Additionally, manufacturers focus on resource conservation and waste minimization, making the process more sustainable. Matches remain an essential part of everyday life for many people, and their production is an important economic sector that supports traditional industries, creates jobs, and generates stable income for many businesses. By combining advanced technology, sustainability, and a commitment to quality and safety, the match industry continues to thrive in the modern world. It might seem that, in the 21st century, lighters should have completely replaced matches, right? But the reality is not that simple. First, matches are an extremely cheap and compact way to start a fire, requiring no additional costs or recharging. They are also highly convenient for short-term use, such as lighting candles, campfires, or outdoor cooking equipment. Another reason is that matches carry a sense of nostalgia and tradition, often associated with a certain aesthetic or atmosphere. In some cases, they are even used in ceremonies, where this small gesture holds symbolic significance. Safety is another factor. Matches do not have mechanical parts or batteries that can fail. For some users, matches provide greater confidence in reliability. So, the next time you strike a match, remember how many people and machines worked to bring it into your hands. And you know what? They did an amazing job. Imagine this. One ship contains up to 20,000 tons of steel. That's the weight of 3 Eiffel Towers. But what happens when these ocean giants retire? Every year, more than 1,000 vessels are sent for recycling, and their materials find new life in bridges, cars, and even other ships. This isn't just dismantling, it's giving metal a second life. Stick around to see how this global process is changing the world. The beginning of the end, or why are ships dismantled? Ocean vessels have an expiration date. On average, that's about 25 to 30 years. After this, maintaining them becomes uneconomical and their structures unsafe. This is where a process, often called shipbreaking, begins. Remember those movie scenes where ships are shattered by waves? Well, no waves are needed here. Just welding tools, massive cranes, and teams of workers who know how to handle these metal giants. First, everything is stripped from the ship. Furniture, electronics, pipes, and cables. Even doors and windows. All of this can be recycled or reused. This process is usually carried out by hand, though sometimes specialized equipment is used. Workers physically dismantle the interior of the ship, unscrewing bolts, cutting metal pipes, removing doors, windows, and panels. It's meticulous, labor-intensive work, requiring attention to detail and strict safety protocols. Imagine this. Cables need to be carefully extracted so they can be sold as copper scrap, and chemicals, such as leftover paint or lubricants, must be safely removed. Even furniture is taken apart to salvage wood or metal components. Of course, on large shipyards, workers are aided by mechanical tools, cranes, gas cutters, and sometimes robots to handle hazardous materials. But the bulk of the work is manual labor. That's why, in countries like Bangladesh or India, where labor is cheaper, shipbreaking is so popular. This stage is crucial because properly preparing a ship for dismantling prevents leaks of chemicals and toxic materials that could harm the ecosystem. Oil, fuel, and chemicals all are drained from the ship to avoid environmental contamination. Once the ship's hull is stripped of everything unnecessary, the gas cutters take center stage. Massive, rusty steel walls, the very structures that once kept the ship afloat, are gradually turned into individual pieces of metal. Workers, dressed in protective suits, stand directly on the hull. Their cutters create bright orange sparks, flying in all directions, producing a kind of steel fireworks. It's both mesmerizing and slightly intimidating. The cutter heats the metal to such a high temperature that it literally melts. But it only looks easy. Ships aren't just piles of steel. They're labyrinths of multiple layers of metal. Sometimes workers have to cut through several layers to reach the right spot. Cutting begins with the upper decks. Large sections are first carved out, like chunks of sidewalls, decks, or even parts of the hull, which are then lifted by cranes and loaded onto platforms. From there, they're sent to factories, where the pieces are recycled into new steel or aluminum. But it's not just about cutting, it's about doing it safely. That's why the hull was cleared earlier of any leftover fuel, lubricants, or other hazardous materials. Without this step, gas cutters could trigger explosions. So, this process is not just labor, it's an art that requires strict adherence to safety rules. And of course, all this happens under the blazing sun or in humid coastal climates. Workers quickly adapt to the heat, and even sparks flying at their feet become a routine sight. In the end, they witness the transformation of a massive, once indomitable ship into mere pieces of metal. It's almost like watching a rebirth. Imagine this. Those massive steel blocks that once kept a ship afloat become the foundation for new bridges, buildings, or even other ships. About 90% of a ship's materials can be recycled, and the largest share is steel. A single large ship can yield up to 20,000 tons of this metal. That's the equivalent of 3 Eiffel Towers in weight. Once the ship's hull is cut into pieces, the next thrilling phase begins, transporting the steel to factories. And trust me, it's not as simple as throwing it on a truck and driving off. These metal pieces are usually so large and heavy that they can't be moved by conventional means. Massive cranes, the kind that look like they could lift a ship themselves, dominate the scene. Their long metal arms with hooks or magnetic platforms carefully grab steel sections and lift them off the ground. It's almost like watching giant toys in action, but everything is done with surgical precision, because one mistake could be costly. After that, the steel is loaded onto huge platforms or special trucks. Regular trailers won't cut it here. You need vehicles with reinforced frames capable of bearing tons of weight. Imagine this. One section can weigh several dozen tons. Sometimes, rail cars or barges are used for transport if the factory is near a port or river. This helps cut down on delivery costs because moving steel is no cheap task. The journey to the factory can be long. For example, if a ship is dismantled somewhere in South Asia, its materials might be sent as far as Europe or America. In such cases, the metal is loaded onto ships again, but this time on cargo vessels. Full circle, right? A ship becomes raw material transported by another ship. Once at the factory, the metal is carefully weighed. Every detail matters, from the total weight to the precise composition of the metal, as different alloys require different processing. Only then does the steel head to the melting stage, where its new life begins. This steel will become new construction materials. Ships continue their legacy, not in the ocean, but as skyscrapers or train tracks. But it's not just steel that's valuable. Ship components also contain aluminum, used in car and airplane manufacturing. Wooden elements, rare in modern ships but present in older ones, are restored and sold for decor. Fabric from old seats is sometimes repurposed into bags or even rugs. Isn't that cool? You buy something stylish and later find out, oh, this was on a liner that sailed the Caribbean. But it's not all smooth sailing. Ship recycling can pose environmental risks if done irresponsibly. Ever heard of Alang? It's the world's largest ship recycling yard, located in India. There, ships are literally beached and dismantled by hand. This method is cheap, but dangerous. Oil and chemicals can leak into the water, and workers often lack proper protective gear. Recently, however, the world has started paying attention to this issue. More and more ships are being recycled at specialized yards that follow strict environmental standards. For instance, in Europe, regulations require the safe storage and disposal of hazardous materials. The largest ship ever dismantled was a container vessel measuring 1,312 feet in length. Imagine taking apart such a giant. This container ship, Ever Given, became famous in 2021 after blocking the Suez Canal, though its end wasn't due to that incident. When ships of this scale are retired, they're usually sent to one of the world's biggest shipbreaking capitals. Dismantling such a vessel likely took no less than a year, because a mountain of steel, cables, equipment, and other materials is a serious challenge, even for experienced teams. Every piece must not only be cut, but also carefully moved, sorted, and shipped for recycling. At the steel plant I visited, everything starts with thoroughly inspecting the metal pieces. They're cleaned of any paint, rust, lubricants, or other impurities that could affect the quality of the steel. Watch as dozens of hands and machines work to prepare this metal for its next journey. Next, the pieces are shredded, cut into smaller parts that are easier to load into the smelting furnace. The process of cutting metal at steel plants is a spectacle in itself, like something out of a sci-fi movie. Huge workshops filled with sparks, heat, and the hum of machinery. These aren't ordinary scissors. They're powerful hydraulic presses, cutting machines, and even lasers. Each tool plays its part depending on the size and type of metal. First up are hydraulic shears. These massive machines can slice through thick steel like paper. They operate under immense pressure, thousands of tons of force that literally crush and cut the metal. Their crunch echoes throughout the workshop. For finer work, gas or plasma cutters are used. A gas cutter operates by burning fuel. Oxygen and acetylene heat the metal until it melts, and then a stream of gas cuts through it. Plasma cutters are even cooler. They create an electric arc that melts the metal, leaving a clean, precise edge. Then there are laser machines. They work with incredible precision, carving out the tiniest details. The laser beam seems to dance across the metal's surface, leaving behind a smooth, polished cut. This is the technology of the future. already in action at many factories. But this isn't just random cutting. Every step is carefully planned. Metal is sorted by thickness and type to avoid damaging equipment. Larger pieces go through specialized conveyors to the next stage, while smaller ones are sent straight to melting. For melting steel, arc furnaces are used. These massive monsters run on electricity, generating temperatures close to 3,000 degrees Fahrenheit. The metal simply melts, transforming into liquid steel. But that's not all. Special substances, known as ferroalloys, are added to the molten mass to enhance the steel's properties. Need strength? Add vanadium or chromium. Want it lightweight? Add aluminum. It's like cooking, but for engineers. Next, the steel is poured into molds, depending on what it's destined to become. These could be sheets, beams, rebar, or even wire. The castings are cooled, cut, polished, and then shipped off for new projects. Building skyscrapers, bridges, or even new ships, all of this can start with the recycled hull of an old vessel. And isn't it amazing? A ship that once carried thousands of tons of cargo across oceans can become part of a car or the frame for a modern stadium. This second life of steel feels almost magical, doesn't it? There are more than 5 trillion pieces of plastic floating in our oceans, and this number keeps growing every single day. Turning trash into something useful isn't just a creative idea, it's an absolute necessity. This approach not only reduces harm to nature, but also proves that even the worst garbage can have a second life. Imagine this, that waste could be turned into something as stylish as sneakers. Surprised? Well, let's dive into this fascinating journey together. First, you need to find the trash. Specialized organizations rely on advanced collection systems to do this. Hunting for ocean trash is an impressive and highly technical process, using cutting-edge tools designed to capture plastic. One of the most renowned organizations tackling this issue is the Ocean Cleanup. They deploy massive floating barriers that are strategically placed in ocean currents, where plastic waste tends to accumulate in large garbage patches, zones of concentrated trash. Here's how these traps work. Large floating structures equipped with nets or barrier walls move through the water, capturing plastic that drifts into their range. These systems are designed to catch plastic debris floating on the surface, as well as some submerged deeper in the water. Imagine enormous nets gliding smoothly through the ocean, sweeping up all kinds of waste in their path. Once the trap is full, it's hauled to a specialized vessel, where the collected plastic is unloaded. This is done using massive mechanical cranes or conveyor belt systems. The unloaded waste is then sorted and cleaned to prepare it for recycling. These technologies don't just clean up our oceans. They create opportunities to repurpose plastic into new products like textiles, sneakers, and even construction materials. The sight of machines pulling massive piles of trash from the water is both inspiring and a little shocking. Plastic of all shapes and sizes, bottles, bags, broken fragments, and even old toys is brought ashore for sorting. It's a stark reminder of the scale of the problem, but also a glimpse of the incredible potential for change. Once the trash is unloaded onto the ship, it's transported to the nearest port. On land, specialized facilities equipped with conveyor belts and robotic sorting systems take over the next stage of processing. Here, the waste is sorted, cleaned, and prepared for recycling. The process moves at an incredible pace. Robotic arms sort the plastic by type, like assembling a massive jigsaw puzzle. This isn't just random sorting. Advanced technology can detect even the tiniest pieces of plastic. After sorting, the trash gets washed. Much of it is covered in algae or other organic matter, so cleaning is a messy, but absolutely crucial step. Sorting is followed by a multi-step washing process. First, the waste is rinsed or scrubbed to remove large contaminants like sand or dirt. Mechanical systems, such as conveyor belts, move the trash through brushes or nets that scrape off big debris. Next, the smaller impurities like oil residues or fine dirt are removed. This can be done in several ways. For instance, as the trash moves along a conveyor belt, high-pressure sprayers rinse it with water. The jets dislodge grime, organic residues, and oil stains. Another method involves submerging the waste in water tanks. These tanks often feature circulating currents, which enhance the cleaning process by gently agitating the plastic and rinsing away remaining dirt. To tackle oil contamination, the plastic is treated with specialized cleaning solutions or chemicals that break down petroleum products and other stubborn pollutants. After these stages, the plastic is finally ready for recycling or disposal. The water used in the cleaning process typically undergoes filtration, so it can be reused or sent for purification to reduce environmental impact. This precise and efficient system ensures the waste is clean and ready for the next step, with adjustments made depending on the material type and its level of contamination. The process of shredding and melting cleaned ocean plastic is truly mesmerizing. A real choreography of technology where each step amazes with its scale and precision. Enormous machines, resembling giant blenders, slice, grind, and crush the plastic into tiny granules. These powerful devices, equipped with massive blades and cutting tools, work at incredible speeds, creating an artificial snow of microscopic plastic particles. As mentioned earlier, the scale of this operation is astonishing. These machines can shred over 1,000 pounds of plastic per hour. The shredded material is ground into granules, which are then sent for melting at temperatures around 500 degrees Fahrenheit. For context, this is the point at which most types of plastic begin to melt and become pliable for reshaping. The roar of massive grinding discs and the compressed sounds of mechanical force fill the air as the plastic is transformed into tiny granules that shoot through the air. Different types of plastic are blended and shredded into a uniform mass. This isn't just waste, it's raw material, ready to be turned into something new. While the granules vary in size, each one is precisely prepared for the next step, melting. These shredded particles are then sent into industrial furnaces for a dramatic transformation. The melting process is comparable to dough that starts off hard and crumbly, but becomes soft and elastic under heat. Gigantic furnaces, heated to extreme temperatures, melt the plastic into a thick, almost liquid state. This molten plastic flows through pipes, gleaming under factory lights like a fiery river coursing through the corridors. In that moment, everything around feels almost magically alive. The melting technology is much like what happens when chocolate or wax is melted into a liquid form. Plastic doesn't just soften, it becomes flexible and easy to shape. At this stage, it's ready to be molded into new items. This semi-liquid material, balanced between solid and fluid states, represents the start of something new, a material reborn to re-enter the cycle of life. As the molten plastic cools, it hardens and takes shape, transforming into products that become part of our everyday lives. This is one of the most captivating stages of recycling, where simple trash turns into something useful, once again finding its place in the world around us. Adidas, Parley for the Oceans, and other brands are already turning ocean plastic into stylish products. For example, making sneakers out of this plastic looks like something straight out of a futuristic lab. Liquid plastic is poured into molds, where it hardens to form the perfect sole. The upper part of the shoe is woven from recycled plastic threads, a kind of textile wizardry that transforms trash into a fashionable accessory. Here's a fun fact. Producing just one pair of sneakers can use up to 11 plastic bottles. These sneakers are not only stylish but also eco-friendly, utilizing materials that might have ended up polluting our oceans. On a large scale, recycling plastic helps reduce dependence on virgin resources. For instance, recycling 1 ton of plastic cuts carbon dioxide emissions by as much as 1.5 tons. One of the biggest names in sportswear even created jerseys for soccer teams, including Real Madrid, made from plastic retrieved from the ocean. Now, players are quite literally wearing the ocean during their matches. What about construction materials? This is another equally fascinating avenue. Plastic granules are mixed with sand or other materials to create durable panels for construction. Ever considered that your home could be partly built from recycled trash? This is becoming a reality, not only reducing the amount of plastic in our oceans, but also cutting carbon emissions in the construction industry. In New Zealand, plastic bottles are being turned into synthetic sand for building roads. This sand is significantly cheaper and more eco-friendly than traditional options. Here's a staggering statistic. Every minute, more than 2,000 plastic bottles enter our oceans and seas. Only about 9% of all plastic waste in the environment is properly recycled. The rest ends up in landfills or the ocean, leaving us with serious concerns about the planet's future. But there's good news. Recycling ocean plastic isn't just about helping nature. It's also a booming business. For example, one company specializing in ocean plastic recycling processes over 22 million pounds of plastic each year, transforming it into sportswear and accessories. In the fashion industry alone, more than 500 million plastic bottles are reused annually to create new products. Many companies are repurposing old fishing nets, which pollute the oceans, into sneaker soles. These fish catchers are now turning into eye catchers when you slip on these stylish kicks. Some companies even craft trendy chairs from ocean plastic, including discarded fishing nets. The irony? These nets used to catch fish, and now they sit in restaurants.